mind that to
This meeting is being recorded.
after the graduation, how an engineer to get the job. So it will help not only to the graduates, even the people who are working in the companies, they can also refer this content to those aspirants who are looking for the job. So uh, basically, I have focused the complete the embedded system aspects here, and the aspirants who is looking to work under the embedded domain. So for them, it will be very helpful. Yeah. So agenda of this presentation, I have listed some of the points. One is what is the need for the embedded system in our uh, world, and what roles and responsibilities you will get in embedded system, and as a embedded engineer which you are going to work, and what will be the tools for there, such as the hardware tool or the software tools and the complete project development tools, and moreover, uh, either you can pick it up the software domain of the embedded industry, what and all the tools to see, and then the hardware development, what are the tools for there, and when it comes to the overall project development, where the software development life cycle will come. So in those areas, there will be a system requirement area, and there is a development area, and there is a testing area. So all these areas, what actually has to be, what tools actually has to be looked on, and what expertise has to be developed. So when they will apply for the job, they can get hired easily with these contents. And then the technologies part, uh, technology part is a complete neutral. Either you are a software developer or a tester or a hardware engineer. So the technology wise, you have to know how. So those things also will be get covered. And then the question and answers. Even the questions will be taken in between as well. So Saif bhai, I will start the things. So first thing, what is an embedded system? We have to understand. Embedded system is purely onto the in the electronics field. Now imagine we have a manual task to do. So that we are doing. Suppose I have an motor, and I want to turn on the motor for one application, such as to pump the water. So in that case, we'll have a electrical switch. We'll turn on the switch whenever the need is there, and then once the water will fill the tank, after that we'll switch off the switch. Now this is a manual task every day people has to do. Now one can think, instead of doing this manually, if this has to be automate, how it will be. So to do this automate, so there should be engineering behind it, where we need to monitor the tank, we need to monitor the electrical supply, and based on this, suppose if the supply is there, then check the water level of the tank. If the water level of tank is low, that time turn on the motor. Now these actions like the sensing, turning on, and controlling has to be taken care by one another entity. So this entity, we called it as an embedded system. And in this embedded system, in this embedded controller, we will find a parts of the electronic hardware, plus a software should be written so to do this job. So basically the embedded system is a combination of an hardware and a software. So once we have this combination, then what hardware modules will come into the picture and what software aspects will come into the picture. So the studying of these two things and clubbing together. So this completion of this part of the task, who is doing, we call them as embedded engineers. Now, once we have the embedded controller in hand, we call this as an embedded system. So similarly, we have lots of embedded systems. We have in embedded system category, we have lots of controllers. Now imagine if we have a calculator, that is also a part of the embedded system. And if you'll see the digital watch, that is also a part of the embedded system. And if you're in your home, you have a washing machine, and with all the electrical sensing capabilities and turning on and off, that is also part of the embedded system. And if you look at your mobile phone, that is also a part of the embedded system. And even now we have the IoT devices, they are also part of the embedded systems. If you go to the bigger picture, like you are using the lift, that is also a part of embedded system. And even more, when you will do your swiping access card, that is also a part of the embedded system. And even if you go to the bigger picture, like a nuclear plants, where all the plant monitoring system will be taken care, that is also a part of the embedded system. If you look at the electric vehicle or any non-electric vehicle, even the fuel engine vehicles also, they also have the much of the 80% of the electronics part into it. Now that also became an embedded system. And we have to think what actually makes this embedded system and the general purpose computers. There is a difference between a general purpose computer and embedded processors. Now, one scenario I will tell, we have a computer or a laptop, and this laptop also have the capability to do the calculations, data recording, you can handle your files, and you can do input output operations. All of those things can be carried in a laptop or a general purpose computers. Now if a user is only interested in the calculator, or if a user only interested in the time, or user is only interested in the data logging, that time, if that type of user, if they selects a computer, it is a excess of their requirement. Their requirement is only the smaller part in that computer. So to help these types of customers who are only interested in the only part of the applications from the computer, this makes the emergence, the origin of the evolving of the embedded systems, where you have a small timers, and these timer with a small mini programming. So this solves the it helps to have the timer related operations. You'll get it in your hand, so this is a compact. So similarly, if somebody is interested in a calculator, they can only have the mini microcontroller that will take the inputs for the calculations, and you will get the outputs. So even that one calculator will come in a size of the palm. And similarly, if somebody is only interested in controlling the mechanical devices, and there have some input and output like sensing the sensors and then the output switches, they require a mini controllers, that's all. So again, that solves the problem in a very smaller compact devices. So rather purchasing the big computer for their use, a smaller mini computers will solve their purpose. So this makes the difference between the general purpose computer and the embedded computing devices. So from this point, I have covered what is an embedded system, and what actually the need of the embedded system, and what makes the difference between a general purpose computer and the embedded microcontrollers. So any doubts you have on this one, please share your points. Okay, so the points which I have discussed, I have listed them here. Moving to the next slide. Roles in the embedded system. Now, this roles in an embedded system, I like to take it in a company view. As we have worked from the startup and to the MNCs, one thing is very common. We have a customers, and the customer will comes with the problems. They have the problem statements, and to those problem statements, we need to find a solution. So first thing, we need to record the problems. What customer have. So after recording this problem, we need to bring what best solutions to solve that problem. So this problem recording and the solution making is a purely a documentation job. So once this documentation part is done, then the next part will comes into the implementation part. Now to do this documentation, there were the certain documenting tools we have. So such as we have a similar, there is a Polarian, there is a Confluence tool, and we have the doors, IBM doors. And even though the smaller version is, we have the Excel sheets. So first we need to record all the problems of a particular customer. Then what actually the solutions will be built. So those things also we have recorded it. So the next thing as a implementation, we need to find out what best hardwares will be used and what will be the software techniques to be used to solve those problems. So all these things need to be documented. So once the system engineering is done, system engineering is not a only of a one-time job. It is like the guiding the project. So once the initial recording has been done and the initial solutions has been tabulated, then how we are going to implement. So in that case, there is a hardware related requirements we have to start gathering it. Once the hardware related requirements has been gathered, and then the software related requirements also started gathering. And after that, these requirements has to be delivered to the hardware engineers and the software engineers to implement it. Once they have done with their implementation, then the next part is to do the testing in on each and every stages. Once this testing is carried with respect to the initial ideal requirements has been tabulated as per the requirement, the testing criteria has to be met. Once this has been met, then the integration phase will come. So during the integration, the same requirements was the customer had, so that need to be met. So once this is also met, the next level of the testing will comes into the pictures, where the even in testing we have the lot of different levels. So functional level is there. Only after the integration we have the functional level. Then the customer side also they will also do the testing. All these things the output has been recorded. So once the final at the customer side testing has been successfully completed, then the products will be get released. So even at this stage also the system engineer have the roles to play. Initially the recording has been done, the at the end what recordings has been done, it has to be get fulfilled. So this makes the system engineer role. And in the system engineer role, so most of the things were technical, but they are not on a hands-on. They have to track the things technically. Even for this role, the experienced candidates will be get preferred. Even the fresher also will be get preferred. Only under the senior guidance, they will get the experience. Second thing, hardware development engineering. So in hardware development engineering, one should know very well about the basics of electronics, electrical, and the communication protocols. And the communication protocol related the hardwares, such as now the communication protocols like UART, we have I2C, SPI, CAN is there, and even at the telecom industry, they have the different protocols. GSM, they have GPS, we have GPRS, and at the semiconductor side also have the different types of protocols. UFS is there, um, uh, NVMe is there, PCI, and when it comes to automotive, there is a CAN FT, and even networking, there is a Ethernet. So Modbus. So these protocol knowledge they should have, and moreover in these protocols, what actually the hardware components they are going to use. So that one. So basics of electronics, communication protocol, and along with that, they are very good circuit designers and the schematic makers and PCB making. So these skill sets they should have. Now the question comes, one can learn the basics of electronics and electricals as well as the communication protocol knowledge. So the next thing, how they can go further with respect to learnings. So one can, if who are interested in this hardware development engineering, so first they have to start building the circuits onto the breadboard. Once they are very good developing the circuits on a breadboard, next they have to take the general purpose PCBs. On this general purpose PCB, they have to start placing the electronic components as per their circuit diagram and then start soldering it, and then they have to carry out their experiments. So imagine, suppose if I have a power supply circuits to design. Now I have selected a AC to DC converter along with the 12 volt output power supply. So here the input first is a 220 volt the AC supply, and the output is 12 volt DC. For this, what and all the electronic components will come. So these components along with the circuit diagram has to make, and then next they have to implement the same circuit diagram on a PCB, and once they give the input 230 volt supply, output expected will be the 12 volt. So this need to be checked. So for this, they should carry a good multimeter, and oscilloscope is also a good one. It should be preferable. So once this first level of the PCB making on the general purpose will come, so the next level they can climb to do the PCB etching. So for that, they have to start exploring what are the chemicals were required and how they can etch the PCB. So what tools they can go for it. This is another option. And the next option is, even though they have designed the PCB, there are the people who have the PCB printing machines. So they can approach them and they can give their PCB so that the printed PCB will come into their hand. From that also they can implement their circuit. So this PCB design, once they are very good, so that makes their complete cycle of the hardware engineering development. So similarly, once the one of the circuit they have completed, the next part is they can slowly explore the different circuits. So by this exploration of the different circuits which comes in a product, so they can be very good in PCB development. So one few techniques for them which I like to give is, take those products which will they will see in a market, and they can think, yeah, this type of products I can develop. So by purchasing those products, and they can open their PCBs, and they can do the reverse engineering of it, what and all, how they have done the tracing, what components they have used. So similar kind of the replications once they keep on doing, so that makes helps them to climb to learn lot of the PCB techniques and the hardware engineering techniques. So once they have developed such those skills, and they can update in their resumes, so they have a good opportunities to work for the uh, better companies. This is about the role of a hardware engineer. Yes, I'll move on to the next part, that is a software development engineering. So this software development engineering will carry a lot of weightage, because here a software engineer should an embedded software engineer should have a 30% of the hardware knowledge, such as basic electronics knowledge they have, and they have the electrical knowledge also, and they can able to read the schematics, and they can able to read the circuits as well. If anything went wrong in between the circuits, they can point out what is went wrong, so it can help them to debug. After this, the next journey of the software engineer is to study the microcontrollers. We have the microcontrollers such as 8-bit microcontroller, 16-bit microcontrollers, 32-bit microcontrollers, and nowadays we are getting the good processors, embedded processors also we are getting it. So if one can start the journey from the 8-bit microcontrollers first. So how, see, we whenever an engineer wanted to learn the embedded software, and they are bringing all the microcontroller related the tools, so that the question comes, what next? How they can start? How they can progress? First, go with the smaller projects. Mini projects is preferable. So they can Google it out. What will be the mini projects first, or either they can have their own problem statements, like first, they can focus from the input output ports, where a digital inputs has been read. According to the digital inputs, what they have read, they have to give the digitalized outputs. So once they have understand about the digital input and output operations, so the next part they can slowly progress with respect to the display devices, reading some inputs and displaying it on a screen. And further they can go with the, once they have done with the displays, they can further move with the protocols, communication protocols with the microcontrollers, and then slowly they can move with respect to the timers, what will be the use of the timers of the microcontroller, and the counters of the microcontroller, what applications they can develop. Along with the timer, counter, digital input output, and the protocols and the displays, they can come up with a very good solutions. Further, they want to explore a communication between one microcontroller to the another microcontrollers. So this makes the level of the engineer, embedded software engineers, to another stage. And then further, they can see the products which are on the market, and they can start trying to replicate it. So this makes them to become an advanced microcontrollers, advanced engineers. So now when they are going to the advanced category, they should be very good in handling the 8-bit microcontroller, 16-bit microcontroller, 30-bit microcontrollers, and what tools they require. Suppose if I am going for a 8-bit microcontroller, there should be a microcontroller related IDEs, integrated development environment. Example, if I'm going to use a 805 microcontrollers, for that the IDE will come as a Kill Microvision. By using this Kill Microvision IDE, one can write the software, one can simulate. Simulate means once after writing the software, even before flashing the software into the microcontroller, they can simulate whether their software is behaving as expected by giving some inputs in the simulation mode and looking output at the in the same simulation mode. So once they are very good in understanding their simulation, so the next part, they can use the hardware simulators, real-time simulators, which comes with respect to the microcontroller IDs. So that is an extra tool they can use so that they can see their hardware, their real-time simulations as expected from the software. So once they have understand about the IDEs and the simulation and the direct hardware simulations, so the next thing, even it is better to study about the JTAGs. So JTAG is one of the tool that helps the engineers to debug it. Now, once already they have developed all the code and they have flashed and they are saying whether the code is working, but at any one point, they are seeing some failures. Now to know where the actually the failure is occurring, now to pinpoint in the software. So so the JTAGs will help to pinpoint the failures in the system in their microcontroller. So this all these setups they can create. So once they are very good in all these concepts and they have climbed up the ladder of the a good embedded engineers. So once they have all this skill set, so even these skill set can be learned even with respect to the tools which are easily available in the online. So they can purchase the tool and they can have the tool in their system installed and they can start practicing it. So what I am suggesting here for the embedded software development engineer is, first they have to dedicate some around 3-4 months time to learn all these things. So basically they have to begin from 8-bit microcontroller and even they can switch to the 32-bit microcontroller also is fine. And they're also, once they are very good at one microcontroller, the understanding of the next microcontroller will be very easy task for them. So the same projects what they have developed for the 8-bit microcontroller, the similar projects they can implement at the 32-bit or 16-bit level of microcontrollers. They can find the difference how a 16 or 32-bit microcontroller is very much easy or very much convenient compared to the 8-bit microcontrollers. So after knowing these differences, even they can develop the very advanced projects also. So once this time once they have dedicated to learn all these things, either they can start picking up approaching to the startups, even they can approach to the good companies for the initial internship, or even they can update the resume and they can post their projects. If the company person are seeing how the engineers have the caliber to accomplish the task, they'll easily get hired. So once this, after this stage, suppose if somebody wanted to have their own startups, even with respect to these skill set, they can easily build their startups. They have to know, next thing is they have to know the guidelines of the developing a product. So in the guidelines, there are some of the C coding guidelines are there. Even though the hardware standard guidelines are there, safety standard guidelines are there. So once they have go through these guidelines, based on these guidelines, if they will develop their products, it will be very good for them to explore more and climb more heights in an embedded industry. So this part is about the software development engineering. So the next part is the hardware test engineer and software test engineer. Moreover, testing is one of the very important and crucial part in an industry, because after the development, if without proper testing, if we'll release product to the market, it is not only the, if the customer fails, if the customer faces any problem with respect to the product, it will be a complete a black mark to the company as well as to the one who has developed the product. So make sure they should do a proper testing at each and every stages. When it comes to the hardware testing, they have their different parameters for it, like the power related, temperature related, signals related. So all these different stages has to be, the product has to go. And when it comes to the software testing, there is a unit testing is there, where the at only the software unit component level there is a testing will go on. And then the functionality testing will come into the picture, where the software is already flashed into the product, and then the each component of that software will be get tested over the functionality. And then there is a integration testing will come into the picture, where the multiple components already has been clubbed, and how the product is behaving with complete functionalities. So this will comes into the picture. And even there are the different testing terminologies were there. So one should be very aware of this testing terminologies and the cycle. There is a unit testing, functionality, regression testing, sanity testing. uh, yeah, this much I can say about the testing. But once who can started to explore, even after going to their actual testing job, they will come to know as per their seniors, as per their company requirements, they can follow their testing guidelines. Now, even for the software test engineer also, the requirements, the learning should be same as per the, they also should know the electronics, basic electronics, and the coding knowledge, and the testing tools, and the IDEs, which will be they are going in the product, which they are using to develop their product. So, and one more part of the testing is there is a black box testing and white box testing. So these two testing types one should know very well, and where their uses. So the next one is a field application engineer. So already once in every company we will see the marketing people, but when it comes to the embedded industry, there are few different areas for there, where there is also a marketing team, but along with the marketing team there is a field application engineer is also there. So for this role also the engineers only required, because here the person who came from the engineering background, who have understood well about the product with respect to the engineering specifications. So once they are going to do the marketing, they can clearly explains about the product with respect to the each and every technical details. So for this, there is a separate field called field application engineer. And these type of engineers also have a very good demand, and they also have a very good future in the embedded industry. So these were the few major roles which I have selected. Even there were the other roles which were there in the embedded industry. If I have script, please try to find them. And if you people are interested, started to work on it as well. Okay. So any question at this point, please you can ask.
No questions, Imran.
Okay, let's move on to the next part. So here the same tools, same slides belongs to the previous. These are the sub slides. as I'm marking in these slides what actually is needed. When it comes to the software development engineering, so hardware test engineering, software test engineering, even in the software test engineering, people can have, we have the test development engineering. That is one of the very good uh, aspects, like with respect to the product and the inputs and outputs which you are giving, testing inputs and inputs, input and outputs which you are going to record. So how for that we will do the automation, like we will again on top of the separately we will write a separate test development scripts. So these scripts can be written on any programming language, C either C++, C sharp, Python, Java. This also can be used. Now the next part is technologies. So an embedded engineer may not going to work on all the technologies in their career. Either they may stick to one or two technologies in their career. So make sure first need to understand what technologies you are interested, and based on those things only start exploring and develop the things. Suppose if one is interested in IoT, so they have to more focus with respect to the embedded software engineering aspects plus Ethernet and Wi-Fi related more. And in even I have mentioned only two here, but inside the IoT, what protocols will be there? So those protocols, they have to be very good, and how they can implement those protocols onto the controller levels. They should be very good. Now, when somebody is interested in automotive domain, so they can be very good in understanding about the CAN communication protocol, and then the AUTOSAR concepts. Here, the AUTOSAR is not a separate tool; it is a standard. So, in this standard, companies will follow certain layer of developing the software. So, those layers need to be understood, and the engineers have the role to do in those layers only. There is a MCAL layer, microcontroller layer. On top of the MCAL layer, there is a basic BSW layer, basic software layer. Again, on top of the BSW layer, there is a application layer. So in these three layers also there is a coding, but one should understand what each and every layer and what part of the coding is going to do. So here the recipe is one should know good in C programming, and they should be good in the Mishra guidelines, Mishra MISCRA C good. It's for the C coding guidelines, and along with that the CAN communication protocol. And in this CAN communication protocol, what will be the other variants for there? CAN FT is there, CAN LIN is there. So those things also need to be understand. And even it is very good if one can implement the CAN communication protocol at the microcontroller level, and if they will try to create the two or three or maybe preferably four CAN nodes to communicating each other. So they have a very good hands-on by building this thing, and they have a very, very good exposure to this domain if they have done the initial experiments like this. And in the electrical, there is a PLC and SCADA. These tools were there. one can understand and go through this tool, but along with that, the technologies with respect to the electrical, the battery system, the motors, and the generators were there, and these things they have to be very good at. They should know the understanding of these major electrical systems. Even they can see the electrical grids, transformers. This helps them lot to understand about the system and how well from the microcontroller they can control this system. Telecommunication side, GSM and GPRS has been mentioned, but along with that, there is a 5 there is a now we are in era of 4G and 5G, so they can understand about this 3G communication, 4G communication, 5G communications. So they should be very good in understanding all these concepts, and so that helps one who are interested to go for the telecommunication domain. And storage, I have mentioned a few things: I2C, SPI, UFS, NVMe, and similarly PCI is also there. And even with respect to the storage, one can be very good in understanding of the uh, NAND and NOR devices. Like we have the ICs, right? So in that IC we have the TTL logics following ICs were there, NAND following logics were there. So these things they have to be very good at. Imagine suppose you are bringing some memory drives, or even you have the different microcontrollers, and the chips developing will be carried on. So how this fabrications will be going to the picture, and after the fabrication, once these devices will come, how actually they work with so this understanding has to be gone. So one can understand about these things. They are very means one who is keen to working onto the storage domain, they can go through this concept. So storage as well as the semiconductor, they will go hand in hand. So semiconductor, where the VLSI technology will come into the picture. This is moreover even the core to our electronics, because on top of the VLSA only we embedded engineers will come. So learning the VLSA and VHDL technology, so that is also one of the very good field. So one can go through. So you may not find the tools easy in hand for this VLSA technology to learn. So one can opt for the very good coaching center where they can get very good tools to do the hands-on for learning the VLSI, FPGA, this thing, because these tools are very costly. So one can um, uh, carefully use them and understand the tools and develop the projects, and even they will have a very good chance of going to the good companies. So others which I have mentioned few of the things such as USB, Bluetooth, infrared, Li-Fi, and computer vision. So they once one can understand about the all these above basics of these technologies thing. Other these tools can be easily they can learn and they can explore the things. So this covers the technologies part. So we have moved to the end of our presentation. So that is a question and answer session. If anybody have questions or queries, you can ask them. You can ask me.
Hello.
Yes.
Yeah, this is Mohammed Imran, and I am
Yes.
currently working as an IT software engineer, but I am
Yeah.
an electrical graduate,
Mm-hmm.
so I can move to this embedded system and where I start. I am quietly good in C++.
Okay. You are good in C.
Yeah.
Okay.
And I want to change my domain to this IT to embedded system
See, you
software.
are good in C and you have done electrical engineering and the present company you are working. So what were your roles and responsibilities in your present company?
Actually, I am working Cognizant as a service IT company and as a support engineer. We are
Okay, in
supporting a
Cognizant,
website. Like,
you are a support engineer. Okay. Uh, in this case, Samil, you
yeah.
need to dedicate some of the time for
Okay.
your learning first.
Okay.
First thing, you should be good in C programming.
Okay.
Now, when you are going to start the C programming, don't start like in our engineering days, you have the chapters and you have to cover the chapters. No. If
Okay.
any chapter you are taking, in that one, go to the either exercise, the questions,
Okay.
and try to see what is this question and how you can solve.
Oh.
Okay, first thing. Second thing, keep in mind such these things like you are learning the C and you have some objectives to complete in C. I will suggest you to take some few projects.
Oh.
Imagine first in Google you type like this C programming mini projects.
Okay.
So list out some 5 projects, which means you got the problem. See, project means here you have some problem statements. So
C or
try
C++,
to solve
which is better?
what?
C or C++?
First, only go with one language. C.
Okay.
Yeah, only one language is enough.
Okay.
Very, very good. Be good in that language first, and
Okay.
then you can second C++. You will understand very easily.
Okay.
Okay. So first take these 5 projects and try to solve these projects. Now here comes your C learning. Now you are trying to solve the project, right? In that time, you refer the book. Now to solve this project, what are the concepts I can refer? Now take the concept and try to implement. Take the concept, try to implement.
Okay.
Now your implementation is started coming to the picture. Once you have done the implementation, right? Then the next time, once you have successfully completed your project, don't stop there. Now redo the same project with different concepts now. You will
Okay.
find multiple ways to solve the problem.
Okay.
Now at this point, you have done with the 5 projects and multiple ways you solve the project. Next, do only one project by clubbing all these 5 by
Okay.
using the same C concepts. Okay.
Okay.
So this helps you to understand better about the programming language.
Okay.
Now, once you have done with this one, now see, now here you make your direction.
Okay.
You are working in Cognizant as a technical, which one?
Now, technical in the support, we are supporting the website. Our client is a US client, and we are
Yeah,
maintaining
you
a
are
website.
supporting, right? Yes.
Yeah, yeah.
Now see, now I would like to suggest some of the thing. First, to see in your own company, you have any friends who are doing any software development or software testing?
No,
Hello?
no. Hello.
You don't have, right?
Yeah.
But try to collect some information, like either in your company, if anybody into the software development side or software testing side, what actually their development, what actually their work which they are doing.
Okay.
Okay. Now, once you got these details, right? So the next thing, if any development engineer you got means, if you got to know anyhow any friends you make, and then try to see what type of work they are doing,
Okay.
and then you try to see whether at your by using your C programming, whether you can able to resolve any some of the problems,
Okay.
or any software test development story is going on, what actually the software test development is going on, or you try to see what your learning C learnings will help into that particular area.
Okay.
Okay, see, by this you try to some problem, you try to develop some applications. One thing, see, once you got to know this thing, the next thing is what role you wanted to go further. You have to see now in your
Actually,
same yeah.
embedded software engineer I like to
Now
support.
the next thing, see, why I am telling to you is you are planning to go to the embedded software means at this point either you can go to any course along with
Oh,
your working.
okay.
You try to go to any good course and do an embedded certification course.
So is it important for doing a course for entering these industries, embedded industries?
Yeah, one thing, see, this is one of the thing which I like to mention. One, why I am telling about the course is you will get one certification. So that is one of the part which I'm suggesting to you. No, you are course you are finding difficulty because you don't have a nearby available any good coaching center and all. In that case, once you have already learned the C programming, right? The
Yeah.
next step for you to pick up some of the microcontrollers.
Okay.
Either you can pick up the 8-bit microcontroller or a 32 or 16-bit. So the related setups you need to create in your home.
Okay.
So once you have the setup ready, like you have a microcontroller, you have some inputs and you have some outputs. So the next thing is you started writing the software onto that microcontroller and see whether your inputs are matching to your expected output.
Okay.
And based on that, you started again here also the same rule. Prepare some mini projects, develop the mini project, and then develop some major project, and these things you have in record. And what I'm suggesting, you prepare a LinkedIn page. In your LinkedIn page you started posting them.
Actually, I am searching some
Yeah.
jobs in embedded system in LinkedIn, but
Hmm.
the HR was they ignoring, rejecting my CV. I don't know.
What happened?
I applied many jobs for in embedded software engineering company.
Yeah, see, I'm not telling about right now jobs, I'm telling about, see, what is the problem when, see, I'm asking some few question in your LinkedIn profile. Have you mentioned C programming, or have you mentioned embedded C programming? Have you mentioned any protocols?
I think no. In my
Huh.
CV there is like C++ completed some courses in Coursera, something like that.
Yeah, correct. But see, the projects which you are doing, the outcomes which you are getting, so those things you post it in your profile.
Okay, okay.
Like I have done some mini projects. So the project detail you post. You did some achievement, you post. By this, inshallah, you will find the people will recognize you. Even though you apply for the job, they will search for some keyword. See, the job searching, when even at this one, right? The people, the HR people who will search for the job, they are not engineers. They will go with certain keywords, and those keywords they match. Then your resume will move to the next level,
Okay.
and that level they will see the technical expertise of yours, how well you solved the problems. Then you will get a call for the interview. Okay.
Yeah.
Huh. And one more another thing which I like to suggest to you is, as you are working in a cognizant, continue your work. See, along with your work, you try to approach some of the startups
Okay.
and see, you ask for any opportunity if they have. Even sometimes some startups will say they have the opportunity, but they may not give you the opportunities as like you are expecting.
Yeah. Yeah.
You can ask for the freelancing. One another way, you take up the opportunity.
Okay.
And then you can have your resume built and approach to the next. Keep your resume uploading. Inshallah, you'll get some calls.
Okay.
See, one thing, Samil, which I like to suggest, even in, I will like to give one small example of ours, like me and my friends who have got the jobs in embedded industry, how actually we got.
Okay.
One thing we were very clear that in our mindset we wanted to go to embedded industry,
Okay.
nothing else. Okay,
Okay.
first thing, mindset we had this one. Second thing, we approached to the company, even we approached to the big companies also, we made the resume, and even we approached to the small companies also. But small companies, with respect to their budget constraint, even they have the different working culture, so where we got hired easily. But we
Okay.
have to you know sacrifice some of the things like salary package wise and all the things we sacrificed. We said, okay, fine, how much you are paying, you can pay. Either it is within 10,000 is also fine, within 20 or 15,000 is also fine. And then after working there for around 1.5 year to 1 year, then our resume got built. Because in the startup we have all the things, like technical wise we have all the things, but we don't have any mentors. But yet we used to do work from the ground level, like we only starts the thing, and if anything problem occurred, we try to resolve it. We'll see the different technical aspect to solve the problem. So those things made us to become an expertise. And once in within 1 year to 1.5 year, our resume means our expertise has been developed, right? Then we made the resume. So this resume was easily get shortlisted.
Okay.
We sacrificed with respect to the salary. We spent the time, and the time we spent, and the next to 1.5 years, in 2 years of time, we started to see the fruit in going only into the embedded industry.
What about the future of embedded industries?
Alhamdulillah, future is there still. Projects are keep on. See, future wise, I'll give some examples. Mm, if I'll take the automotive industry, now in automotive industry there are a lot of trends are coming. Means the new technical trends will come, are coming. You are saying you are going to see next is the all the electric vehicles.
Yeah.
So
Yeah.
this is one of the trend. Okay.
Yeah.
And once this trend will keep on going, next inshallah you may see the drones, human carrying drones. You will see this my trend will come. So in all these stages the engineers were required. So based on this only you will get hired.
Oh.
And next I would like to suggest this telecom side. See, in the telecom side also you are seeing that normal different technical trends.
Oh.
And even in storage domain also you are seeing, we are seeing different trends. Like earlier we have the hard disk, mechanical hard disk. Next you
Oh.
are seeing the SSDs.
SSD. Yeah. So to speak.
Okay, so now even you are seeing the even smaller form of the SSDs. So these projects are years of projects. Like it is not a 6 months project or 1 year project. They have the 3 year, 4 year, 5 years of time. And even once they'll start, they'll keep on going 20, 30 years. Still it is moving like that. See, one thing which I like to tell you is, see, before picking up the embedded industry, you should be, see, if you are not going to do that job, maybe already tomorrow behind you already there will be one other person who are able to do that job. You got my point?
Yeah.
So it's you who has to take up the courage. If you are picking up on path, I don't care for any other thing. I'm doing it for my own. First thing, your own happiness should be there. Moreover, what you earn, how much you earn, that is second thing. First thing is how well you are content. Okay. So the path which you are going to select, you should be self-satisfactory that even though I'm not getting what I'm expected from others, but the work which I'm doing, I'm content. Initially, when we are working, we used to get lot of blames like still you're on that much salary, still you're on that much salary. My friends also used to say, colleagues, relatives also used to say. But one time came, now they will stop asking that how much you are earning, because it shoots up beyond their expectations also. Okay, see here in embedded industry, one more thing which I like to suggest. See, you have a mindset like not to be settling type. It's all to be achieving type. You climb to one level means you should not stop there. You have to climb to the next level.
Continuous learning, like that.
Huh?
Continuous learning. Right?
Continuous learning and continuous achievement. You need to bring a new change every time. Okay. Hope these points will help you to think and take up a good decision. Okay. Okay, Samir. Thank you.
Thank you, Imran.
Thank you. Saif bhai, I have
Okay,
done with
Imran
the
bhai.
presentation.
Yeah, Jazakallah. It was
Thank
very
you.
effective and very good advice about the jobs related to embedded domain. Inshallah, help others also. Okay, with this we can close the session.
Sure,
Okay, thanks a
sure.
lot, everyone. Assalamu alaikum.
Walaikum assalam.
Walaikum assalam.